Hey guys, welcome to my third video lesson. It is about chapter 1, length, area, and volume. So let's get started. Question 1, how many mouthfuls to a gill, a cup, and a pint? So here we have our conversion chart, and we have our math over here already. So to get to this point, we have to start something called dimensional analysis. And what dimensional analysis is it is the act of converting one unit to another. So hence the conversion chart, because we have to know what each thing equals, because we can't just get a mouthful to a gill. We have to actually go down and convert everything. So over here on our math, we see, let me get a pointer up. All right, so first we've got to start out with 2 mouthfuls over here. 2 mouthfuls is going to equal 1 jigger. So we put it down here. We put 2 mouthfuls on top of the line and 1 jigger on the bottom, because we want to get rid of the jiggers and we want to keep the mouthfuls, because that's what we need to know equals another one. So here we have 2 mouthfuls is equal to 1 jigger, and then we make another line, and because we want to get rid of the jiggers, we'll put 2 jiggers equals 1 jack. We get from right here. 2 jiggers will go on top because we want to get rid of the jiggers like that, get it away, and that will equal 1 jack. So over here we have 2 jacks equals 1 jill. And so we'll put 2 jack up on top of the line because we want to get rid of that jack right there, and that's going to equal 1 jill. So here we have our jill and our mouthful already up there. So because you see we have 2's up here, we can't do anything with the 1's, obviously, because 1 in math isn't going to equal anything. So we'll do, because they're on top of the line, all the numbers we want to use, we'll do 2 times 2 times 2, and that's going to give us 8. So we have 8 mouthfuls to 1 jill. So now the second one is how many mouthfuls to a cup. And as you can see, we're going to have the same 3 conversions, the first 3 that we had up here. So, you know, jiggers are going to cancel out, jacks are going to cancel out, and then we have 2 jills to 1 cup. So we're going to put the 2 jills up top because we want to get rid of the jills. And now we have our 2 mouthfuls in our 1 cup. So again, we're just going to do the same thing that we did at first. So we're going to add 1 more 2 to our multiplication already. So 2 times 2 times 2 times another 2 is going to be 16. So we're going to have 16 mouthfuls to 1 cup. Now the third one is going to be how many mouthfuls to 1 pint. And again, the same thing with the second one. We're going to have the first 4 of the conversions be the same as the first and the second one. And we're just going to have 2 cups equals 1 pint added. So again, we're going to get rid of the jigs, get rid of the jacks, the jills, and the cups. And now we're left with our 2 mouthfuls and our pint. And so again, we're just going to add another 2 to the multiplication. So we'll have 2 times 2 times 2 times 2 and times 1 more 2. And that's going to give us 32. So we'll have 32 mouthfuls to 1 pint. All right. So question 1B. What happens when an empty pail is loaded with 1 jigger, 1 jack, 1 bottle, and 1 gallon? So you see here we have our little 2-gallon pail, and again our conversion chart just so we can look at it. So we see down here that 1 pail is going to be equal to 2 gallons. So we already have this over here. Our pail is a 2-gallon pail. And we know that we're already going to have 1 gallon added to it already. So that takes out one of our gallons. We have 1 more gallon to fill. So we have 2 bottles is going to equal a gallon, but we only have 1 bottle being put in there, so we're going to have a half gallon. not one, a whole one. So then we're going to fill it with 1 jigger, which is going to be 2 mouthfuls, and 1 jack, which is 2 jiggers. So that means that we'll have 6 mouthfuls basically go into the pail. So when all of that is filled, our 1 gallon, our half gallon, and our 6 mouthfuls, we will have room for 1 more mouthful. All right, so question 2, finding perimeter and area of these 3 triangles. So the formula for perimeter is side plus base. So for the first triangle, triangle A, we're going to do our side, which is 48.3 meters, plus 68.6 meters, plus 80.9 meters, and that's going to give us 197.8 meters. So then for triangle B, we're going to have 90 inches, plus 97.5 inches, plus 37.5 inches, and that's going to give us 225 inches. So then on C, I know it looks a little complicated, but this is actually the height of this one, of this side right here. So we don't need that right now, we need that for the area. So for just perimeter, we're just going to use the 3.3 instead of the 2.2. So we're going to do 3.3 centimeters plus 8.2 centimeters plus 5.2 centimeters, and that's going to give us 16.7 centimeters. So now the area for the formula for area is going to be base times height divided by 2. So for triangle A, we have our base, which is the 80.9 meters, and our height, which is the 41 meters, and you're going to divide both of those by 2, and you're going to get, let me find it, you're going to get 1,658.45 meters squared. And you're going to square the meters because you're using multiplication. So then for triangle B, we're going to have our base, which is the 90 inches, times our height, which is the 37.5 inches, and then divide that by 2, and we'll get 1,687.5 inches squared. Again, you're doing the square because of multiplication. So then over here for triangle C, you will now use the 2.2 centimeters because it is the height of this side right here. So we have 2.2 centimeters times our base, which is going to be 5.2 centimeters down here, and then you're going to divide that by 2, and you'll get 5.72 centimeters squared. All right, so question 3, which is larger, the area between the circles or the smaller circle? So first things first is we know the length of the square is going to be, the length of the square is going to be 22. And the equation for the area of the circle is pi times radius squared. So the diameter of the circle, so here's, that's going to be our radius. So the diameter of the circle is going to be the same as the length of the square. So to get the radius, you do diameter divided by 2. So if it's the same thing as the length was 22, you'll do 22 divided by 2, and your radius is going to equal 11. So then you'll do the equation, and you'll do pi times 11 squared, and you're going to get 121 pi units squared. So then the radius of this larger circle right here is going to be, you have to use it, you have to get it by using the Pythagorean theorem, which is a squared plus b squared equals c squared. So you're going to plug and chug your numbers, and you're going to do 11 squared plus 11 squared equals 242 pi units squared. So to get the how to know which is bigger is you're going to subtract those. You're going to subtract 242 pi units squared minus 121 pi units squared. And then you're going to get 121 pi units squared again. So because you're going to get the same answer, it means that the area, the region's area is going to be the same size. So neither one is larger than the other because they're going to equal each other. All right, question 4, how to find the ratios of the cone to the sphere to the cylinder. All right, there's our sphere, cone, and cylinder. So the volume of the cone is going to be 1/2 times base times height, and the base of the cone is going to be pi times radius squared. So the volume of the circular cone is 2/3 times pi times r squared. And the volume of the cylinder is base times height. So the base of the cylinder is going to be pi times r squared, and you substitute the height 2r and the base area pi radius squared into the equation for the volume of the cylinder to get 2 pi r cubed, or 2 pi cubed, I'm sorry, not r. The volume of the sphere is 4/3 pi r squared. And now you just divide the volume of each shape by the volume of the cone, because the volume of the cone is going to represent number 1. So volume of the cone divided by volume of the cone is going to equal 1, ratio 1. Volume of the sphere divided by volume of the cone is going to equal ratio 2. And volume of the cylinder divided by volume of the cone is going to equal ratio 3. So 1, 2, 3 is going to be our ratios. Right, question 5. Find the surface areas of the two figures. So we're going to start with the first figure right here, number 1. And we notice that the base of this figure is a trapezoid. So you will do the area B of a trapezoid with bases A and B with altitude h, and it's going to give you the formula B equals 1/2 parentheses A plus B in parentheses times h. So we're going to plug and chug that, and we're going to get 246 centimeters squared. So for the base. So next we're going to find the perimeter, which is just going to be adding those, and you're going to get 66 centimeters. So you see our equation down here. We're going to plug and chug those numbers into this equation. SA equals 2B plus PH. So we're going to get 2 parentheses 246 in parentheses plus 66 times 5. And that's going to get us 822 centimeters squared. So now we're going to do the second figure down here. And we notice that it has a triangle base. So the formula for that is going to be the same thing, 1/2 times base times height. And the area of the triangle using the formula is 30 meters squared. So the perimeter, doing the same thing we did up top with the trapezoid, is going to be 30 meters. So using our SA equals 2B plus PH equation, we're going to get 2 parentheses 30 in parentheses plus 30 times 7. And that's going to give us 270 meters squared. Right. So for our last question, question 6, it's going to be find the surface area and volume of the two solids. So let me go ahead and label our figure 1 and our figure 2. Now, what we're going to do is we're going to separate these by our spheres, which are on these two ends, as you can see, and then right here, our cylinder. So the equation for the surface area of the sphere is S equals 4 pi times radius squared. So doing the lateral area of the cylinder, which is right here, the 16 feet, you do S equals 2 pi times radius times height. So you're going to do you're going to add those together. So you'll get S equals 2 pi times R times height plus r pi times radius squared. So plugging and chugging that, you'll get 2 pi parentheses 5 feet in parentheses, 16 feet, in parentheses, plus 4 pi, parentheses, 5 foot squared equal, approximately is going to equal 817 feet squared. So to get the volume, you're going to do 4/3 pi cubed plus pi radius squared height times height. So plugging and chugging that, you're going to get 4/3 parentheses pi in parentheses 5 foot in parentheses plus pi parentheses 5 foot in parentheses squared parentheses 16 foot in parentheses, and you'll get approximately 1,780 feet cubed. So now for our second figure, we're gonna split it again with the cone and the cylinder, and we're gonna get we're gonna add these again. It's gonna be the same equation that we did the first time, the pi radius squared plus the 2 pi radius height, and you're gonna plug and chug those numbers that we have up on our figure, and we're gonna do pi parentheses 5m squared plus pi parentheses 5m in parentheses 7m in parentheses plus 2 pi parentheses 5 meters in parentheses 13 meters in parentheses, and that's going to approximately equal 597 meters squared. So the volume to get this, what we're going to do is we're going to do the square root, and under the root we're going to do 7 squared minus 5 squared, and so that's going to equal 4.90. So to do that, you're going to plug and chug this equation again, and you're going to do pi times 5 meters squared times 13 meters plus 1/3 pi times 5 meters squared times 4.90, and you're going to get approximately 1,149 meters cubed. And that's how you find the surface area and the volume. All right, guys, that's all I've got for today. See you guys next time. Thanks.